Hey everybody. I will start with an old joke. So a programmer is about to leave to the grocery stores, and her husband asks her, "Honey, can you please buy some bread? And if there are any eggs, could you please buy a dozen?" And she goes to the store. She comes back, and you can imagine his surprise when she brings back a dozen loaves of bread. So we obviously have a problem here, right? So what if the problem is in the if, right? If he didn't give her any choice, there wouldn't have been any trouble, right? So unfortunately, computers are really bad at working without if clauses or without branching in general, without switch, without ternary operators and stuff like this, because they will be able to do only one thing.
Nossa, 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 nossa.
And this is not really good, right? And culturally, people, we also really like choice, because we can't live otherwise without choice, right? We really need it. So we will have to look at the problem somewhere else. And where else would be the problem? People talk about if a lot, but people rarely talk about else. And you can see that in English books, the word if is actually seen more than 10 times more than the word else, which is a lot. So people like if a lot more than else. And however, in computer programs, the word if is actually seen only 4 times more than else, which means that in computer programs we have 2.5 times more else clauses than if clauses. Why is there such a big difference between natural language and code? Because we are kind of supposed to express with code what we want to say with natural language, right? And I will try to give you a few reasons, but first, let us try to track a typical logic statement with ifs and elses, right? We have an if with condition 1, and this piece of code will be executed if condition number 1 is true, right? Then this piece of code will be executed if both conditions 1 and 2 are true, right? Then we go to an else, where we have to change our context in the sense that condition number 2 now has to be false when we are trying to read the code. And the same thing happens for the rest of the else clauses. We have to always do a context switch every time we are reading an else. And historically, context switches has been really hard, both for computers and for people doing our everyday jobs. So before we continue, let us look at what would a statement containing only if clauses would look like, without any elses. We will have to remember that this code will be executed only when the first condition is true. This code will be executed when both the first and the second conditions are true. The next piece of code will be when all of the first 3 conditions are true. And finally, the last piece of code will be executed only when all 4 conditions are true. So we don't do any context switches. We're just adding more context. And in general, for people and historically, change is bad. People never like change. But people actually like building stuff, and they like adding more and more stuff. nobody likes migrating laptops, but everybody likes new laptops, right? And so now I will take another try at explaining why there are so many more else clauses in programming compared to in natural language. And I think the reason is that else clauses help us explain a much more complicated logic. And we use a more complex logic a lot more when we talk to computers than when we talk to people. Because computers are a lot better at understanding logic, right? And unfortunately, people are not at all great at understanding logic. We are just too lazy, we are too bored too easily, and people also fall really easy for logical fallacies. But I don't know how many times have you tried to trace an algorithm you wrote, and it is always incredibly annoying to keep all of the state in our minds. And it is because people are just inherently not great at following state. Just ask the React guys. However, people are really great at recognizing patterns. I'm pretty sure you can all read this, even though it is not any meaningful text, right? Just people are really good at for example, as you can see, they're really good at recognizing text, even though all of the letters in the middle have been scrambled. They're also really good at recognizing faces immediately. I'm always amazed how border control officers let me in and out of countries really quickly, even though in my passport my photo looks like this. But it usually takes them like half a second to make sure and to know that I'm just the same person. And usually it takes software because they now have those small cameras. It takes the software usually a few seconds at least. People are also really good at recognizing sounds. If you know a song, usually you can recognize it just from a few beats. And usually it takes Shazam like 15-second excerpt, right? So in a lot of sense, we are even a lot better than computers at recognizing various patterns. And science has totally confirmed that our brain is basically a huge and amazing and really fast pattern recognition machine. Actually, there have been some studies showing that our brain works really like a recursive probabilistic fractal, which actually science is trying to use for recognizing faces. So from all this, we can draw a pretty simple rule that if in our programs we use more patterns and less else clauses, it will be much easier and it will take a lot less time for the person who reads them to understand what is going on. And by patterns, I certainly not necessarily mean design patterns from the Genga 4 book, if you're fans of those. In my remaining time, I would try to show you a few examples of tricks about how you can eliminate else clauses from your programs. The first one, which is probably the most common and easiest, is to emphasize the essential part or the main flow of our code. Here is a really typical example where if some data is valid, we do something with it, and if it's not, we return false, right? Or no, sorry. I'm sure everybody has written a lot of code for situations like this. And see, we can The essential part of the code is now in pink, and this is where we actually process the data. The rest is like, there is a really neat term called accidental complexity, which is all of the stuff we need to write, all of the plumbing we need to put so that our programs work the way we intended them. And here is a very quick way to make sure that our essential complexity, the important part of the code, is emphasized. If we first bail if there are any errors, we can achieve a few things. First, all of our essential code can be together. Also, it will not be indented somewhere further in our program, so that we know if something is in the main indentation level, it is probably something important and not just error reporting code or error checking code. Another trick to eliminate else clauses is to use polymorphism. Actually, you used to think that polymorphism was a multi-headed monster from the Greek mythology, but it turned out that it is the method of being able to use the same logic for data with different types. And I'll give you another example here. I'm sure everybody has done something like this. We have to render a field or whatever object, and this field can be in different types. Like in our case, if it's a text, we render an input. If it's a number, we have our special component. If it's a text area, we render a text area, or we throw some exception. So if our goal is to eliminate else clauses here, it will be pretty hard. And we can go back to polymorphism, which, to remind you, is to find a piece of code which can work somehow with any type. And the common pattern here is that for each type, we have a specific component we just render. And for example, instead of keeping all of our structure in if clauses, we can keep it in an object, and we can use the type as a key. I'm sure all of you have done this a lot of times. It is not rocket science, and I see a lot of people actually do it. But it's important to remember those tricks when we have a bigger application or we have a really complicated expression and we wanna eliminate else's one by one. So if you're into classic OOP books and stuff, there are two things which can help you with using polymorphism and give you a lot of background on this subject. One of them is the classic strategy design pattern. You can check out Gang of the 4 book if you haven't before. Just please take it with a huge grain of salt. The other classic thing which can help you with this is the refactoring book by Martin Fowler. And one of the refactorings there is called Replace Conditional with Polymorphism. There are a ton of ideas there about how to do that. So people really love patterns. And actually, they will often see patterns where no patterns actually exist. For example, there are experiments showing that if you start showing people random dots, when people are overwhelmed, they will actually start seeing patterns because our brain cannot handle a really complicated world. Our brain is always trying to make sense of the world around us. And for example, when you get more and more dots, which are totally random, for example here, it turned out that a lot of people do not see random dots, but they start seeing poodles, right? Or you've seen people looking at the clouds and seeing, I don't know, monsters, bears, or people looking at already drunken coffee cups and trying to predict the future. It's our way of telling, it's our way of, that our brain tells us, oh, it's owed to too complicated. I want to make it simple again. And here is an example where it could be a problem in programming. Let's say we have this. These are a lot of if and else statements, right? So if a person is reading it, after probably the second or the third, they will get the general pattern. Oh, we are just checking about type, right? And then something happens for a specific type. But there is a great chance they will not see that we actually broke the pattern in a few places. So it is really important to have our patterns in a much simpler ways. Like, for example, if this was in an object, it wouldn't be so easy for us to break the pattern. The next trick is to put more focus on the action we are doing and not so much on the intricacies of the logic. Here is an example. Here is the logic of a kid in the spring season, basically anywhere in the world. If it's a weekday, it goes to school. If it's not a weekday, but if it's a Saturday, it plays football. And if it's raining, it watches TV because they can't play football. And on Sunday, obviously, kids have to do their homework sometimes. And if it's winter, we, like bears, really like to hibernate. So how can we make this simpler? Because when you look at it, you don't see any actual pattern. It is just a random logic going back and forth. And here is what we can do. We can just focus on the action themselves and not so much on the conditions. Humans, as we are pretty bad at keeping state, so they usually try to avoid it. And very often we are pretty explicit in what we say. So we will usually not say that, oh, if it is spring, I will go, and if it's a weekday, I will go somewhere. Instead, we usually say, oh, on a spring Saturday, I would go play football. And you can see here that it is really easy to see the pattern of all the important stuff. And these are the actions, right? Sometimes it is really hard to escape the conditionals. And we don't have to go into too much trouble. So if there is no visible way to escape from them, at least the least we can do is to simplify and make everything shorter by extracting stuff. We can extract methods. For example, this monstrous thing can just happen this by extracting a function in the middle and giving it a proper name. Or we can extract a conditional and again giving it a proper name. If people tell you that they don't like so much abstraction, it is really important to point out that this is indirection and not abstraction. We're not abstracting things too much. We're just putting it inside in a very well-named functions. And usually it is pretty obvious what do they do. As a closing, I would like to say that writing code is actually a lot closer to user experience and usability than we think. Because across us sits a normal person. And we need to make sure that when they read our code, it is easy for them to understand, and it doesn't take them too much time. In the end, people are a lot more important than computers. And as Mr. Abelson said in the really great structure and interpretation of computer programs, that computer programs are written for people to read and only accidentally for machines to execute. Thank you.